We our chapter 5 is system communication. Can we move on, guys, on this chapter, or anybody have any doubt? Okay, Leo, not Neo. I am talking about Leo. Yeah, okay. Okay. Now we are moving to our next chapter, which is system communication. Here we actually understand the parts and of through which the system will communicate, right? Firstly, we are moving to motherboard. Okay. Okay, what does one mean? What did you think? What it actually is? Motherboard in a simple term, right? Can anybody explain? Guys, please, bro, Ethan or Leonic, any of you. What do you understand by just this word? It contains two words, right? Mother and board. You can actually break them down and then, yeah, you know. So please tell, what is it? Answer it right now. Why? Okay, did you have any problem in your mic or you're outside? So I think that you can answer using your mic. Just wait. Okay, let me tell you what motherboard actually is. It is the, you can say that it is the basic skeleton or the basic body, right, of our system. Just wait, bro, wait. Yeah, please tell me what happens to you. Okay. What happens to Leo? Did you have any problem? I don't think so. Okay. Uh, I'm talking about motherboard. Okay. So motherboard is the main circuit board that connects and allow communication between all the computer uh, components, right? For example, CPU, RAM, storage, GPU, network card, USB, etc. I don't know that whether you know the meaning of all of these components or not, but you have to, for right now, you just have to remember that what is the function of motherboard. It uses to connect or provide communication, establish communication between all of the computer components, right? If we take a look here, then motherboards for PC, right? This is something like, yeah, okay. This is a kind of motherboard, right? Hope that you can see here. Here, everything, this is L1 cache, L2 cache, and here it is processor. No, actually, yeah, here it is processor. And bro, just wait. Yes, okay. I think I should maximize it. Okay. Hope that you are able to see that there are a lot of very small components are arranged here in a particular format. These USB drivers here, right? So basically, what it actually is, hope that you got what I want to say, right? That motherboard is a kind of, हम उसको कह सकते हैं कि मतलब पूरा एक तरीके से बॉडी है, राइट, जो कि पूरे जितने भी डिफरेंट टाइप ऑफ कंप्यूटर के जो कंपोनेंट्स हैं उनको कनेक्ट करके रखती है, राइट? डिड यू गॉट इट व्हाट मदरबोर्ड एक्चुअली इज? It's heart of the computer. Yeah, you can say it's heart of the computer, you can say. But mainly if we tell it as body, then it might be that because it uses to actually connect all of those things, right? All of the component. Okay. Now it provide communication and the power path, right? Means the electric connection or the electric packets have to flow, and the communication packets also have to flow from one component to another. That's why it provide a path to both of them, right? What are the main component of it? Its socket, the CPU socket, RAM slot, in which RAM is uh, RAM will be मतलब जिसमें RAM लगती है, right? PCIe slot. It is also a slot where PCIe puts into the motherboard, right? We have learned about all of those things. What is chipset? What is PCIe, right? Then the main component also include chipset, then BIOS and UEFI chip, which is also means it can also known as firmware chip, as all of these things are known as firmware. Then it is storage connector, which is where our hard disk drive or SSD will connect. For example, SATA M.2. SATA is actually older one, right? It I don't confirmly know that whether it is used and present or not, but it is older one, right? And then we have power connector, for example, uh, chargers, right? Just wait. Okay, bro, Shivash will come tomorrow because his driver, Shivan's driver, is crashing right now. Okay, so yeah, these are the main components of our motherboard. What is the flow of command, right? Firstly, from our CPU, whenever we trigger any instruction or any program, it firstly went to CPU, and after CPU it went to motherboard, right? Here CPU act as a input, right? We give input to CPU, then CPU send it to process to motherboard, and motherboard then allocate RAM, SSD, GPU, USB, network card, etc. Right? Hope you got it. Yeah. Uh, Ethan, did you got it that what motherboard actually is, and what are the different components? Right? We are going to discuss about these components. Might be in detail. Yeah. Okay. Okay. Now this is the flow of our command. Now a simple question here, that why can't component communicate without the motherboard? So it's simply because motherboard provide the physical connection and the communication pathways, right? If you have seen the lines on the different chips and the motherboard, for example, on did you have open a charger or any other electronic device? Any of you? Did you have open or not? Unique or Ethan? I'm asking with you, bro. You have open? आप लोगों ने कभी किसी ऐसा इलेक्ट्रॉनिक डिवाइस को ओपन किया है? इसके अंदर जो प्लेट लगी हुई होती है, राइट? दैट इज ऑल्सो मदरबोर्ड, बट एट द स्मॉलेस्ट लेवल. या in TV remote as well. In every almost in every electronic device, motherboard is there, right? Okay. Now we are moving to our next uh, thing. After motherboard, we are moving to buses. What a bus actually is, right? So a bus is a communication channel that transfer data between computer components. Now, hope you got that. Motherboard provides the route or the path, while bus takes the data from different channels. You hope you that you know the meaning of channel. Unique, did you got it? You know the meaning of channel or not? Okay, yeah, you know. So, bus is a communication channel, right? That transfer means it is. What is the purpose of bus in our real life? Just same, the copy paste here as well, right? It uses in real life. It transfer passengers, and and this motherboard it transfer data from different computer components. So there are three type of buses, all for different purposes, right? First type is comes as data bus, which transfers actual data, right? Means if we say that which bus transfer data, then we have to take name as data bus. Then the another kind of bus is address bus, which carries memory address, right? These are two different things. First, data bus says that what the data actually is, and the address bus says that where the data have to execute. And then if we move to a third bus, which is control bus, then it says that what carries signal, right? Means what actually we have to perform with that. Either we have to read or write or interrupt or clock, right? Hope you got the difference between all the three buses. Did you got the purposes of all the three? Okay, then you don't know, you don't got. Okay, एक काम करते हैं, देखो हम डाटा को डिवाइड करते हैं, राइट? अगर आप कोई भी काम करोगे, राइट, इन टेक एग्जांपल ऑफ आर रियल लाइफ, अगर आप फॉर एग्जांपल के आपसे बोला गया कि आपको एक पार्सल है, उसको किसी के यहाँ डिलीवर करना है, राइट? सो ओके, सो हियर टेक पार्सल इज अ डाटा, राइट? जब आपके पास मतलब अगर आप कोई भी पार्सल डिलीवर करने जाओगे तो आपको पहले पता होना चाहिए कि एक्चुअलिटी में मुझे डिलीवर क्या करना है। उसका आंसर है पार्सल। कहाँ पे करना है वो आपको बता दिया जाएगा, जो भी करना है, राइट? और उसको दे के क्या करना, मतलब सिर्फ उसको दे के आ जाना है या उसको ओपन करके देना है, उससे और भी कुछ चीज लेना है कि नहीं लेना, ये सब आ जाता है कंट्रोल बस में। होप दैट दिस एग्जाम्पल इज क्लियर टू यू। यस, सो नाउ the three type of bus: data bus, address bus, and control bus. Carries control signal, carries memory address, and transfer actual data. Make sure to remember these buses in your memory, because it is one of the concepts which normally everyone get forget, right? Now we are moving to a scenario example. CPU wants data, right? CPU को data चाहिए है। एड्रेस बस, इसका काम होगा मेमोरी एलोकेशन का, राइट? मेमोरी एलोकेशन मीन्स हमको डाटा चाहिए, राइट? सीपीयू वांट्स डाटा, तो जो एड्रेस बस है वो मेमोरी एलोकेट करेगा, सॉरी मेमोरी लोकेशन करेगा, राइट? कंट्रोल बस जो है वो रीड करेगा, एंड देन हियर द डाटा बस विल रिटर्न द डाटा. These are the three functions which all the three different buses performed when the CPU wants data. Does this example, did you understand this example clearly? Did you got it? Unique, okay. If any of you any doubt, then please tell me at the same place, right? Because if you don't understand this, then it might be that you have to suffer in the upcoming classes. Okay. Now here as well, what is the difference between data bus and address bus? Okay, the purpose of mine for taking these questions in between, so that you can actually understand that how you have to answer in a technical term, right? Because we know हम लोग ऐसे normal terms में तो अपना जो भी हमको definition या आंसर देना होता है वो दे देते हैं, but technical terms में हम नहीं दे पाते, right? वही एक problem बन सकता है. So this only tells you that how you have to use the technical term while giving the answers, right? So what is the difference between data bus and address bus? So data bus transfer data, while address bus specify where the data is located, right? Now we are moving to next thing, which is chipset. Okay, hope that buses are clear to you. Okay, now we are moving to chipset. We only take its overview. The chipset managed communication between the CPU and other hardware. Okay, this line already tells everything about chipset, that its main purpose is to manage communication, right? It is just act like a traffic control or traffic manager inside the motherboard, right? Its responsibility is to stabilize or check USB communication, SATA or NVMe storage. These are the two kinds of storage. Right now, NVMe is more popular as compared to SATA because it is much faster. NVMe much faster than SATA, right? According to me, it is much faster. I haven't deep researched on both of them. And then PCIe devices. We will discuss about PCIe devices uh, in the upcoming paragraph, right? And then it will also take control over network and audio. Means basically what a traffic controller, how a traffic controller actually works in our normal environment, right? जो एक ट्रैफिक पुलिस होती है वो नॉर्मली बताती है कि ये जाना चाहिए, अभी ये वाला लेन ओपन करो, ये वाला लेन ओपन करो. जस्ट सेम फंक्शंस, चिपसेट फंक्शंस द सेम थिंग हियर, राइट? कौन सा कम्युनिकेशन, कौन सा सिग्नल कब कहाँ पे जाना चाहिए, दिस इज कंट्रोल्ड बाय चिपसेट. Modern CPUs handle RAM directly, right? Chipset are not available in modern CPUs, but maybe in few of them it might that you uh, found chipsets as well, right? Well, chipset manage slower peripheral. Okay, chipsets are available, but they don't come in most use, right? Mainly the direct handle RAM, right? RAM will direct handle all the communications and etc. How the data will flow, right? Means just like that. This is just a data cycle, sorry, signal or the communication cycle. From CPU, it will went to chipset, and then after chipset, as it act as a controller, so it divide all of the signals and the path to these different USB, SSD, audio, Ethernet, etc. Right? Why is a chipset needed? So because it manages communication between CPU and peripheral devices. Now we are moving to few terms. These are the two terms which we need to understand before moving to peripheral component interconnect express, which we have take a look on above. PCIe, right? So what are the two terms? First of them is serial communication interface. A communication interface that a communication interface that transfer one bit of a data at a time over single communication channel. Did you got the meaning from? I means it is actually in very simple language, and it might be that you should understand the meaning of it, right? That a single bit of data transfer at a single time over a single communication channel. There are over means I think in thousand or in crores or maybe in lakhs, right? At our motherboard, there are a lot of the channels available, right? So what a serial communication interface actually it actually transfer one bit of data at a single time from a single communication channel. And then what is expansion device? So expansion device is actually a hardware component added to a computer to provide new features or improve existing capabilities. For example, GPU. What is the working of GPU? GPU means a graphical processing unit, right? जब हमारे कंप्यूटर्स पहले के टाइम के जो कंप्यूटर्स थे, ऐसा नहीं था कि वो काम नहीं करते थे, राइट? दे विल आल्सो वर्क, but whenever we comes to gaming, right? So actually their data gaming or high GPU intensive work, then actually they can't transfer data much more efficiently, right? That's why we need GPU. So what GPU actually did, it enhance the speed or the quality of data transfer, right? Same as NVMe SSD, we have other storage as well, right? Other storage or memories architecture as well. But NVMe actually enhance the power or enhance the capability, right? So expansion devices are the simply the devices which used to either uh, expand on the features of our machine, right? or add something new to our machine, right? Did you got it? Did you got this chipset overview here? If anybody have any doubt, then please, unique or other. I think you have doubt in it, right?
The second one.
What?
In the second one.
In these expansion devices.
Yes.
एक्सपेंशन डिवाइसेस मीन्स अगर हम इसको और सिंपल टर्म्स में बोले सो फॉर एग्जांपल के पेंसिल एक्सटेंडर देखा है जो मतलब अपना नॉर्मल कभी कभी ऐसा आता है अगर आप लोग पेंटिंग या आर्ट करते हो तो जब आप एक पूरी किट मंगाओगे तो आपको एक पेंसिल एक्सटेंडर मिलेगा, राइट? वो होता है कि अगर आपकी पेंसिल छोटी हो जाए तो आप उसको पेंसिल एक्सटेंडर में लगा के उसको एक्सटेंड करके लिख सकते हैं या एक्सटेंड करके उसका ड्राइंग कर सकते हैं उससे, राइट? What it does, it actually provide one more feature to the smallest pencil, right? मतलब जो आपकी पुरानी जो पेंसिल थी उसको एक्चुअली इसने एक न्यू फीचर ऐड करके कि उसको थोड़ा सा और एक्सटर्नली उसको लंबा कर दिया कि आप उसको यूज कर पाओ. Expansion devices are the expansion devices are the devices which actually used to either add something new capability or add something new feature to your hardware or enhance the uh, older one, right? For example, Wi-Fi card. You can connect your system through cables, right? ये जो अपना cables होते हैं हम इसके थ्रू अपने systems को connect कर सकते हैं. But Wi-Fi card जब से आया हमारे systems पे, right? So we can actually communicate just using Wi-Fi and the hotspot signal, right? Now did you got it? Yes. Unique. Okay, Unique also got it. So now we are moving to next thing, which is PCIe Peripheral Component Interconnect Express. It is the full form of PCIe Peripheral Component Interconnect Express. PCIe is the high speed serial communication interface. Here, the same thing means such interface which transfers single bit of data at a single time from a single communication channels, right? So it is the high speed serial communication interface used to connect expansion devices, right? Now I think that this definition become easy for you to understand that to connect different kind of expansion devices, we have a high speed serial communication interface which is known as PCIe or Peripheral Component Interconnect Express. It is used for graphic card, which is GPUs, right? Also NVMe SSD and Wi-Fi card, capture card, AI accelerators, etc. Right? Did you got it that what PCIe actually is? I want you to please means don't remember the thing, right? Means don't just remember the definition. Try to think about it a bit and try to go a bit deeper, right? So that you can actually understand where the problem actually is in your understanding, right? Okay, so now we are moving to, okay, there are different kind of PCIe lanes, right? Means from a single lane, right? Data will single amount of bit will transfer from a single lane, right? Hope that did you got it, because this is a serial communication interface, so it will only transfer a single bit through a single lane. Right? Lane means hope that you know the lane जो अपने रोड पे डिफरेंट काइंड ऑफ लेन बने होते हैं. Yeah, that. Either you got it? Yeah, okay. So there are different kind of lane, which is PCIe lane. Sorry, PCI lane are of different kind. For example, there may be one lane, there may be four lane, there may be eight lane, and there may be 16 lane. Can you tell me that why we only have one, four, eight, or 16 here? Any of you, please, first. Unique or Eden?
Because the power of 2 is the experiment bit type like that.
Yeah, just because of the base of binary, right? It is two. The base of binary is two. Hence, it is, you are right, unique. Okay. So now these are the different kind of lens. Just for example, अगर हम इसको एक नॉर्मल अपने फिजिकल वर्ल्ड में देखें तो at national highways you have lot more lanes as compared to the normal highways, right? And from if you take a look on the road which are inside city, then they have lanes less as compared to the highways, right? So that the traffic will be less. Did you got it? That what I'm trying to say? I just wanted to say that more the length, more the bandwidth it is. Bandwidth it actually means the transfer of data, right? The amount of transfer of data, or you can say speed. In simple term, bandwidth is also known as speed, right? More the LAN will be, more the bandwidth also available for transfer of data. Did you got it? That why more LAN is equals to more bandwidth? Yeah, okay. So now examples, for example, GPU, right? GPU have 16 lanes, PCIe lanes, right? It is just example, right? GPU maybe it may be that it have more lanes, right? And NVMe SSD have 4 lanes, right? That's why SSD is we can say slower as compared to GPU, right? Just due to the LAN. Okay, how the command will, how the information will flow? It's flow from PCI, sorry, GPU to PCIe, and then to, sorry, CPU to PCIe, and then GPU. Right, it is the flow of information normally, right? Firstly, it information comes to CPU, then it take a lane from PCIe, and then it moves to GPU. Now question, what does a GPU use, sorry, why does a GPU use X16 lane, right? Just because to increase the bandwidth, or have X16 have very high bandwidth or the capacity to store to move data, right? Did you got this PCIe? It is just like a lane or a road, right? Did you got it, Ethan? Okay. Now we are moving to interrupts. Actually, interruption here the interrupt actually means to interrupt, right? The word and the function of this thing is both the same. It is a signal, right? Interrupt is a signal that tells the CPU to stop its current work and immediate handle an important event. Okay. अगर ओके, बेसिकली इंटरप्ट करता क्या है? तो इंटरप्ट जो है वो सीपीयू को बताता है कि जो प्रोसेस अभी आप कर रहे हो, जो या जो काम कर रहे हो, उसको यहीं पे स्टॉप करो, और एक जो न्यू प्रोसेस या जो न्यू वर्क आया है उसको हैंडल करो, उसको स्टार्ट करो, राइट? क्या होगा अगर हमारे पास इंटरप्ट्स नहीं हुए, राइट? सो अगर हमारे पास इंटरप्ट नहीं हुए, सो वी विल कीप प्रेसिंग आवर कीज फ्रॉम कीबोर्ड, राइट? बट CPU don't stop, right? It will only stop after completing a single process, right? But if we wait for that much long, so it actually wastes our time, right? Wastes of CPU time. Here it is written that it is wastage of CPU time if we don't have interrupt. Whenever we press any key, interrupt signal generate, and it will send to CPU, and from there uh, the process which is already running will stop, and a new process or the immediately process will be start, right? uh, with interrupts, when we press keyboard, interrupt sent, and the CPU respond immediately, right? Now example, for example, keyboard inputs, mouse movement, timer, disk completed, network packet received. If any of these kind of activities happens there, uh, mm, mm, don't take a look on this network packet, because we will understand it in our networking module, right? Network packets, you will understand it there. So if any of these kinds of activity happens or triggers, then our interrupt packet is interrupt signal is actually generated, right? And what will be the flow? So the flow is starting from actually device, right? Device or the hardware, maybe the motherboard as well, because if a motherboard receive a data packet, right? Sorry, a network packet, then it is a start from motherboard, right? Hope you got it that we need not any external device. It can be started from internal devices, right? So firstly, our signal will, firstly, our information or data will flow from device to interrupt. Means after device, it actually generates the data, actually generates the interrupt signal. It moves to CPU, then interrupt handler, which used to handle the task and resume the previous task. Okay. Hope you got it. Why are interrupts better than polling? So interrupts just notify the CPU. Sorry, interrupts notify the CPU only when needed, while polling wastes CPU time by constantly checking the devices. These are the two different things. I think that okay, just move this question from here. Don't take a look on this question, right? Right now because we haven't understood what polling actually is. Did you understand this whole interrupt? We can say the paragraph here, right? Unique, did you have any doubt? No. Okay. Now we are moving to our next thing, which is device controller. A device controller is a hardware that manages communication between the CPU and a specific device. Now it might be that you get confused with the above one as well, where okay, where it handles communication. It is an interface. Okay, just its chipset. Okay, it manages communication. Right? Don't get what I said. Don't get confused with both of these. Right? It actually manages communication between CPU and other hardware. Right? Chipset. While these device controller is actually the hardware which manages communication between the CPU and a specific device, right? Did you have any doubt between both of these? One manages, means both actually manages communication, but actually it is hardware based, right? Device controllers are hardware based. Did you got it? Device controllers are hardware based, while chipset, I think that chipset is software based, right? It also manages communication between the other hardware and the CPU. Now here we are. Okay, here we are here. Now, for example, CPU controller, disk controller, right? These all are the different kind of control which used to control the hardware, right? Or the different kind of hardware available for us motherboard, right? These all are actually connected to our motherboard. Firstly, right? How does it work? Firstly, a task flow from CPU to device controller and then the actual device, right? Means like that I have to open my Wi-Fi, right? Then what it actually does, it the CPU receives the signal that okay, the user wants to start Wi-Fi services, right? और लेट्स दैट आई वांट टू कनेक्ट राइट मैं अपने कंप्यूटर को जो या मेरा जो सिस्टम है उसको मैं इथरनेट के थ्रू कनेक्ट करना चाहता हूँ राइट सो फर्स्टली आई विल कनेक्ट then CPU get that information, it will transfer it to device controller and then to the actual device, right? For example, here, yeah, here the same thing also happens. जब भी आप एक pen drive लगाते हो, right? So what happens? The signal moves from CPU to USB controller and then from USB to pen drive. Then only we are able to see the pen drive in our system that it is actually connected, right? The CPU communicate with the controller, not directly with the device. This is the very important statement here, right? Don't think that CPU directly communicate with controllers, right? Sorry, yeah, directly control communicate with devices is actually communicate or contact with controllers, right? Now we have few Linux experiment. Okay, firstly tell me, did you understand till here? This device controllers clear to you all? If you have any doubt, then please raise your doubt. Don't have any. Okay. Let's take a look on these Linux experiments. Just wait. Let me start my machine. So, bro, what happens to you? You still have to power off it. No, 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 no. I don't want you to start. Just power off. Okay. So we have my Kali machine. Let's see what we have to do. We have to list our USB devices, right? LSUSB. Okay. Right now I have connected a single Ethernet wire to my main laptop, right? And also an external keyboard and an external mouse with my charging cable, right? So let's see that how many things can it will show to us. Is it visible to guys? Visible to all of you? Okay. So where we are? Okay, here it is. We have to write LSUSB, right? It is a command list USB devices. Okay. So it actually list five things, right? Don't take a look on both both of this because I actually run a virtual machine, right? Hence both of these will come. It actually gives me three more things, right? The USB hub through which I connected my Ethernet, right, or my phone. It has the virtual mouse. It actually the virtual mouse is actually written here because I have uh, I use this machine in VMware, right? Otherwise it should be written as mouse, simply mouse, right? So I have one virtual mouse connected, one USB hub connected, which is my Ethernet, and one keyboard connected, right? Uh, so hope that LSUSB is clear to you. It lists all the USB devices which are connected to your system. Is it clear? Okay, now let's try the another one which is LSBLK, which is used for list storage device. LSBLK. Yes, so here it is. I have given 80 GB storage to my Linux machine, right? Here, if you see, this is 80 GB, right? Although this machine is another one and this is the another one, but I have given the same amount of hard disks to both of them, right? I have allocated 80 GB, hence here it also show me as 80 GB of storage. Here G means GB, right? LSBLK. So okay, LSBLK tells us about the tells information about the all the storage devices, right? And now we are moving to hardware information, LSHW. To view the hardware information, we have to use LSHW. Okay, it will show the hardware information to us. Now, if you take a look on it, then it is very long information, right? Uh, uh, I don't know where it will end. I don't think so that we should go to full above, right? You can see that here it is PCI 3, PCI 4, right? These are the same PCI which we have discussed earlier, right? So what you can actually see by using this command, right? LSHW, you can actually get all the information about your device, right? Uh, okay, here you can say that you can see why it should, maybe there is some problem in it. Power button, input 1, input 2. Where is the keyboard? I got confused. Okay, hope that you got the purpose and you got a practical implementation of all these three means all these three commands, right? Did you got it? Using LSUSB, we can list all the USB device which are connected to our machine. And then using LSBLK, we can actually list all the storage devices. If I connect some more partitions or more disks to my virtual machine, then uh, here at the place of this only SDA1, we might see few more uh, disks, right? And then LS, by using LSSW, you actually get the more information, right, about your system. Now, what are the device? Why are the device controller required? Because they translate CPU command into device-specific operation and manage communication at hardware with hardware, right? At the system level or at the hardware level. Hope you got the purpose of device controllers as well. It actually controls different kind of devices, right? You got it, Ethan? Okay, so this is our chapter number 5, which is our system communication, right? Here is one live definition for to summarize everything. Just wait. Okay. We have motherboard, which is the main circuit board that connect all hardware components. Then we have buses, which can be named as a communication pathway for transferring file data, addresses, and control signals. Chipset, these manages communication between the CPUs and peripheral devices. PCIe, which is high speed interface for connecting expansion devices like GPU and NVMe SSDs, and expansion devices, and such devices which used to expand either the features or introduce new features to our machine, right? And then we have interrupt. These are the kind of signals which tells the CPU to immediately handle an event for an emergency case, right? It is just like an emergency case. And the device controller handle hardware that control communication between the CPU and specific devices. Hope that this all these things have clear to you. If any of you have any doubt, then please. Uh, my screen is visible to you, right? Okay, yeah, it is visible. Okay. So with this summary, we are actually going to close our class today. If any of you have any doubt related to anything, then please ask. Otherwise, we are going to wrap it up. Unique or Eden, any doubt? No. Okay, Eden, you also don't have. Okay. So can we wrap it up for today? Okay. So we will meet to our next class uh, tomorrow at the same time, 9 p.m. Right? Till then, yeah. Thank you very much for myself, right? For me, actually, yeah. Okay. हाँ बस थैंक यू वेरी मच ज्यादा की जरूरत नहीं है बहुत ज्यादा हो रहा है चलो ठीक है